To us, the Milky Way feels endless. A glowing river of stars cutting through the dark fabric of the night sky, stretching so far that it seems to dissolve into infinity. When we look up, we're struck by a feeling that's both humbling and intoxicating. The idea that we are surrounded by a cosmic ocean without shores. The stars appear countless, the distance is immeasurable, and the galaxy itself eternal. Yet this breathtaking sense of enormity is not truth. It's perception. The illusion of infinite size is born from our limited perspective. We live inside the Milky Way, unable to step outside it and see it in its entirety. It's like standing inside a vast forest. From within, it feels endless because every direction looks the same. But seen from above, that forest has borders, edges, and a definite size. The Milky Way only seems boundless because our senses can't grasp distances measured in light years. Our human experience, measured in miles, hours, and days, is far too small to comprehend galactic scales. So our minds translate incomprehensible vastness into the feeling of infinity. But in truth, what we call infinite is just finite space, too large for our imagination to measure. That illusion, the belief that our galaxy is beyond limits, is the first veil that must be lifted to truly understand how small the Milky Way really is. When we strip away the illusion of infinity and turn our gaze inward, not with wonder alone, but with science, the Milky Way transforms from an endless mystery into something tangible, measurable, and profoundly structured. It is no longer an ocean without shores, but a vast island in the cosmic sea, with contours, edges, and a story all its own. Our galaxy is immense by any human standard, stretching roughly 100,000 light-years across and about 1,000 light-years in thick in its disk. That means if you could travel at the speed of light, it would still take you a full 100 millennia just to cross from one side to the other. And yet, despite this astonishing scale, the Milky Way is only an average-sized galaxy in the grand architecture of the universe. It's a spiral galaxy, a graceful pinwheel of stars and dust, turning endlessly in the silent vacuum of space. From above, it would appear like a glowing whirlpool, its arms curling outward from a bright, dense center like a celestial hurricane. From within, it's a realm of light and shadow, of newborn stars igniting in clouds of gas and ancient suns burning their last fuel in quiet corners of the disk. Inside this grand spiral lives an estimated 200 to 400 billion stars, an almost unthinkable number. To put that into perspective, if you were to count one star per second without pause, it would take you more than 10,000 years to finish counting them all. And that's only the stars. The Milky Way also contains countless planets, perhaps trillions of them, along with asteroids, comets, and immense nebulae where new worlds are still forming. Hidden among this glittering population are exotic objects like neutron stars, pulsars, and black holes, remnants of suns that have lived and died over billions of years. At its heart lies one of the most mysterious entities in the known universe. Sagittarius A, a supermassive black hole weighing roughly 4 million times the mass of our sun. Everything in the galaxy, stars, gas, dust, and dark matter, slowly orbits this gravitational giant. It's the invisible anchor that holds the Milky Way together, the dark core around which our entire galactic disk spins. The stars near it move at tremendous speeds, whipped around by the sheer force of its gravity, while our own sun, far out in the suburbs of the galaxy, takes around 230 million ending years to complete just one orbit. That means in the entire history of humankind, our solar system hasn't even made a single full revolution around the galactic center. And yet, despite all this grandeur, the billions of stars, the immense scale, the intricate structure, the Milky Way is still just a speck in the observable universe. To grasp that, imagine that the galaxy's stars are grains of sand. If each star were one grain, our Milky Way would form a shimmering beach that stretches for miles. But beyond that beach are billions of other beaches, each one its own galaxy, each one filled with its own stars, planets, and possible civilizations. What feels infinite to us is, on a universal scale, just one small island among billions. Another way to understand the Milky Way's true size is through its structure. Our galaxy is composed of several key regions: the galactic disk, the central bulge, and the halo. The disk is where most of the visible action happens. It's where the spiral arms stretch outward, dense with young stars. The bulge at the center is older, thicker, and filled with ancient stars orbiting in chaotic patterns, remnants of an earlier time when the galaxy was still forming. Surrounding it all is the halo, a vast spherical region containing scattered old stars and dark matter that extends far beyond what we can easily see. The halo itself might be several 100,000 light-years in diameter, filled mostly with invisible material we can only infer through its gravitational effects. But what's perhaps most humbling about all this is how small the Milky Way is in context. We often think of a few 100 billion stars as unimaginable abundance, and it is. But it's still just a drop in a cosmic ocean. Astronomers estimate that there are more galaxies in the observable universe than there are stars in the Milky Way. Every single one of those galaxies might contain hundreds of billions of stars of its own. The total number of stars in the universe could reach sextillions. That's a number so large it defies language itself. So while our galaxy may feel infinite from within, it's just a tiny eddy in an incomprehensibly vast sea of galaxies. Even more astonishing is that our galaxy isn't static. It's alive, in motion, constantly evolving. New stars are born in the vast nurseries of gas and dust, while old stars die in supernova explosions that scatter heavy elements, the very building blocks of planets and life across the galaxy. These processes have been repeating for over 13 billion years, shaping and reshaping the Milky Way like cosmic tides sculpting a shoreline. Over time, our galaxy has also collided and merged with smaller galaxies, absorbing them like rivers feeding into a larger current, and in the future it will merge again. This time with the Great Andromeda Galaxy, which is slowly drifting toward us in a dance that will culminate billions of years from now in a galactic union. So when we speak of the Milky Way as our home, it's not merely poetic, it's literal. Everything we know, everything we've ever observed with human eyes, exists inside this one swirling island of stars. Yet for all its brilliance, the Milky Way remains just a whisper in the vast choir of the cosmos. 100,000 light-years may seem infinite, but the universe measures distance in millions, even billions of light-years. Compared to those scales, our galaxy's immensity fades into insignificance. And this is where the perspective deepens. Because within this magnificent but finite spiral lies something even smaller. Something that defines our place in the grand story of existence. A single star and the tiny system of planets that orbit it. Our solar system, for all its splendor and mystery, occupies an almost laughably tiny corner of the Milky Way. Everything we have ever known, like every planet, every asteroid, every spacecraft we have ever launched, every human story ever told, all of it exists within one modest neighborhood of this vast galactic metropolis. If the Milky Way were a grand spiral city of stars, our solar system would be tucked away in one of its countless suburban streets, far, far from the glowing bustle of the galactic core. We live in what astronomers call the Orion Arm, or sometimes the Orion Spur, a minor spiral branch that stretches quietly between two of the Milky Way's major arms, Sagittarius and Perseus. It's not the heart of the galaxy, nor one of its grand avenues of stars. It's a smaller, quieter region, an interstellar suburb, neither too crowded nor too empty. From here, the galactic center lies about 27,000 light-years away, hidden behind thick curtains of cosmic dust and owl. Even though the center of the Milky Way blazes with billions of stars, it's invisible to our naked eyes, obscured by the dense clouds that fill the plane of our galaxy. We those in our little corner see only fragments of that brilliance. A faint ribbon of light that arcs across the night sky, whispering of the immensity we cannot see directly. It's humbling to realize that our entire solar system, the sun, its 8 planets, their moons, the asteroid belt, the Kuiper belt, and even the distant Oort cloud, is but a tiny bubble in this local neighborhood of space. To scale it properly, if the Milky Way were as wide as the continental United States, the entire solar system would be no larger than a coin. Even the outermost edges of our sun's gravitational influence wouldn't reach beyond a microscopic fraction of that galactic span, and yet inside that minuscule speck lies everything we hold dear, from the fragile blue marble of Earth to the frozen reaches of Pluto. The Sun itself is not particularly special among its peers. It's an average G-type main sequence star, a middle-aged sphere of hydrogen and helium burning steadily for about 4.6 billion years. There are billions of stars like it in the Milky Way. Cooler red dwarfs, hotter blue giants, and everything in between. Some are orbited by worlds far larger and stranger than ours, others by lifeless debris or nothing at all. Statistically speaking, our Sun is one of hundreds of billions of other lights that populate this spiral disk. Indistinguishable from afar, another glittering dot among countless others. And yet within this one unremarkable system, something extraordinary has happened. Around a small star and a minor arm of a modest galaxy, life emerged. A planet formed just the right distance from its star, not too hot, not too cold, and over billions of years, it nurtured seas, continents, and eventually consciousness. Humanity's existence, in cosmic terms, is an improbable flicker in the quiet suburbs of the Milky Way. The civilizations we've built, the art, the technology, the dreams, all of it unfolds on a single world orbiting an ordinary star, surrounded by an incomprehensible multitude of other suns. It's easy to forget how fragile that context is. When we look at images from spacecraft like Voyager 1, which even after traveling more than 15 billion miles hasn't left the solar system, we see just how small our cosmic home truly is. In the famous pale blue dot photograph, Earth appears as nothing more than a mote of light suspended in a beam of sunlight. From that distance, our planet is almost invisible, and yet that speck contains the entirety of human history. Carl Sagan's words still echo with quiet truth. That's here. That's home. That's us. When viewed from a galactic perspective, even our grandest achievements, the Apollo missions, the probes we've sent to the outer planets, our radio messages flung toward distant stars, remain confined within a vanishingly small bubble of space. We've barely stepped off our doorstep in galactic terms. Our entire species has existed for less than the blink of a cosmic eye. And in that time, we've managed to explore only one small planet and its immediate surroundings. To visualize this, imagine the Milky Way scaled down to the size of Earth. On that scale, the solar system would be smaller than a bacterium crawling across its surface. The distance from our Sun to the nearest star, Proxima Centauri, would still be several millimeters. An enormous gulf, even in this miniature analogy. That's how tiny our place is, a microscopic system orbiting a single star and a faint, unremarkable arm of a galaxy that itself is just one of billions. And yet, despite our smallness, our location has advantages. Being far from the galactic core keeps us safe from the chaos of densely packed stars, intense radiation, and the gravitational mayhem of the central black hole. The Orion arm is relatively stable, giving life on Earth billions of years to evolve undisturbed. It's a quiet neighborhood in a busy city, a perfect refuge for life to emerge and wonder about the cosmos beyond its sky. In this calm pocket of the galaxy, the Sun and its planets drift slowly through the darkness, orbiting the galactic center at incredible speed, over 800,000 kilometers per hour. Yet to us, everything feels still. Space is so vast that even at those velocities, it takes our solar system hundreds of millions of years to complete one revolution around the Milky Way. By the time we finish a single orbit, the continents on Earth will have shifted, the stars we see today will have moved, and perhaps humanity itself will be something entirely different. Or gone. So while we may speak poetically of our place in the stars, that place is infinitesimally small, a quiet corner in one of the galaxy's countless spiral arms. Every discovery we've made, every dream of exploration, every scientific breakthrough has happened within this tiny galactic suburb. We live in a cosmic neighborhood so remote and so insignificant that if you could zoom out far enough, it would vanish entirely into the haze of starlight. And yet, the very act of recognizing this, of knowing where we are, is what makes us extraordinary. From this speck of dust in the Milky Way's outer suburbs, consciousness has emerged that can not only look up at the stars, but also understand its own insignificance among them. That awareness connects us not just to our galaxy, but to the entire universe. Our solar system may be small, but it is from this smallness that wonder is born. And when we look outward, beyond our sun and planets, we begin to see the true scale of what surrounds us. and how even within the Milky Way itself, we are dwarfed by numbers and distances too vast to imagine. When we pull back even farther and look at our solar system from the perspective of the galaxy around it, our sense of scale begins to collapse into insignificance. The sun, the blazing heart of our solar family, the giver of light and warmth, the very reason Earth is alive, is in the grand scheme of things painfully ordinary. It is one of hundreds of billions of stars within the Milky Way, and nothing about it stands out in the endless stellar sea. If you were to drift through the galaxy at random, the odds of picking out our sun among the countless others would be almost zero. It's neither the brightest nor the biggest, neither the hottest nor the oldest. It's just one unremarkable point of light among billions, one of the galaxy's countless lanterns burning quietly in the dark. To the human eye, the sun seems immense. It dominates our sky, commanding everything in our solar system with its gravitational pull. It's so vast that over 1 million Earths could fit inside it, and yet within the Milky Way, this blazing sphere is just a grain of sand lost in a cosmic desert. The stars around us are so distant that even light, traveling at nearly 300,000 kilometers per second, takes years, centuries, even millennia to reach them. The nearest star system, Alpha Centauri, is more than 4 light-years away. To put that in perspective, if the sun were the size of a coin, Alpha Centauri would be another coin 4,000 kilometers away. That vast emptiness lies between nearly every star in the galaxy. A silent gulf of space so immense that even our most advanced spacecraft would take tens of thousands of years to cross it. And beyond Alpha Centauri lie the true legions of the Milky Way, hundreds of billions of other suns, most too faint or too far away to ever see with the naked eye. Some are colossal blue giants, burning through their lives in a few million years. Others are tiny, cool, red dwarfs, destined to shine for trillions of years after our sun has long faded. Around many of these stars orbit planets, worlds we can only glimpse through telescopes, their surfaces forever hidden from our sight. Some may be barren, frozen spheres of rock and gas. Others might harbor oceans, atmospheres, and perhaps even life. But the truth is, we will never reach the vast majority of them. The distances are too enormous, the speed of light too slow, and our technology too fragile against the enormity of time and space. Even if humanity survives for millions of years, colonizing nearby stars, we will have barely touched the edges of our own galaxy. Traveling from one end of the Milky Way to the other, even at the speed of light, would take 100,000 years. And since we can move at only a fraction of that speed, the journey becomes unimaginable. The galaxy's vastness is not something we can conquer. It is something that humbles us into silence. Every star we see twinkling in the night sky is part of our own Milky Way. Yet even then, we are seeing only a sliver of its population. A few thousand stars out of hundreds of billions. The rest remain hidden beyond our sight, veiled by dust, distance, and time. If the Milky Way were a massive city glowing in the dark, our sun would be one tiny window in a single building, in one neighborhood, on one quiet street. And even that analogy exaggerates our importance. Astronomers estimate that only a fraction of all the galaxy's stars are visible from Earth, even with telescopes. The rest lie too far away, their light too faint to reach us. Many of them will never be known to human eyes or minds. They exist, burn, and die without ever being witnessed. It's a humbling realization. Most of the Milky Way will forever remain unseen and unexplored. The scale is so immense that even if every human ever born spent their lifetime studying a single star, we would still never run out of stars to study. The galaxy is that vast, and we are that small. What's even more staggering is that many of these distant stars host their own systems of planets. Thousands of them confirmed, and likely trillions more awaiting discovery. And yet, from where we stand, all of that is compressed into the faint shimmer of the Milky Way in our night sky. When we look up and see that hazy band of light, we are looking toward the heart of our own galaxy, where billions upon billions of stars blend together into one continuous glow. Each dot, each glimmer, each trace of that luminous band represents entire solar systems, entire worlds, entire histories, playing out far beyond our reach. And amid all that, all those stars, all those systems, our sun, the very center of our existence, becomes invisible. From the outskirts of the galaxy, even if one could look back, the sun would be indistinguishable from every other faint point of light. The star that sustains every breath we take, that shaped our planet and our lives, would vanish into the background noise of the Milky Way's radiant expanse. That's how minuscule our home truly is. It's easy to feel lost in that vastness, but there is also beauty in it. The smallness of our place is not a flaw. It is a reminder of the universe's grandeur. We are not the center of the cosmos. We are a fleeting consciousness that arose in one tiny corner of it. The sun's ordinariness is what makes it profound. Out of one of hundreds of billions of stars, it managed to create conditions perfect for life. It reminds us that even in a galaxy so large, the extraordinary can be born from the ordinary. Still, as we acknowledge this humbling truth, the perspective keeps widening. For even if the Milky Way holds hundreds of billions of stars, it is still only one galaxy, a single glowing whirlpool among billions of others scattered throughout the observable universe. The numbers we've spoken of, stars by the 100 billion, light years by the 100,000, are about to become small themselves, dwarfed by the distances and scales that lie beyond our galactic home. Because when we look beyond the Milky Way, we find that our galaxy, magnificent as it is no more special than a single grain of sand on an endless cosmic shore. When we speak of the Milky Way's size, 100,000 light years across, it feels like we've reached the upper limit of imagination. 100,000 years for light, the universe's fastest traveler to cross from one end to the other. That distance alone dwarfs everything we know, planets, stars, even entire civilizations. To us, it sounds impossibly large, but in the vast geometry of the universe, the Milky Way's immensity shrinks into near insignificance. Because between galaxies, between the true islands of the cosmos, lie gulfs so great that the entire Milky Way could vanish inside them without leaving a trace. Let's pause on that number, 100,000 light years. A beam of light moving at 186,000 miles per second would take that long just to cross our galaxy's width. To us, that's staggering. Yet the space between galaxies isn't measured in hundreds of thousands of light years. It's measured in millions, even tens of millions. The nearest spiral galaxy to ours, the majestic Andromeda, sits about 2.5 million light years away. That means that if the Milky Way were reduced to the size of a dinner plate, Andromeda would be another plate placed on a table several feet away, with vast, empty darkness in between. And what fills that in-between space? Nothing. Or nearly nothing. It's an almost perfect vacuum, a void where even stray atoms are few and far between. Galaxies are like lighthouses in an endless night, each one isolated from the next by incomprehensible distance. The gaps between them are so enormous that, for most of cosmic history, each galaxy lived in near solitude, unaware of its neighbors except through the faint whispers of gravity. In our human understanding, large is a relative concept. The distance from the Earth to the Moon feels large, 384,000 kilometers. The distance to the Sun feels impossibly large, 150 million kilometers. But even that is nothing compared to the distance to the nearest star, which is over 40 trillion kilometers away. The mind buckles under such numbers, yet those are still within our own galaxy. When we talk about the distances between galaxies, we leave behind the comfort of even astronomical numbers. We step into scales that redefine what large can mean. Imagine this. If the Milky Way were the size of a coffee cup, the nearest galaxy would be several continents away. The vast stretches of intergalactic space that separate these cosmic structures are almost beyond the reach of metaphor. It's a scale that refuses to be visualized, one that strips our language of meaning. Far, large, and distant. None of these words are built to describe millions of light years. Even light itself, which seems unstoppable, struggles to bridge these gaps. The photons that reach us from Andromeda began their journey long before humanity even existed. They have been traveling through the darkness for millions of years, unbent, unbroken, until finally they strike our telescopes and tell us of another island of stars out there. Those faint glimmers we see in the sky are ancient messages from distant galaxies, snapshots of a cosmos as it once was, because in the universe, distance and time are inseparable. To look far away is to look back in time. So, when we call the Milky Way large, we are really speaking from within the confines of our own smallness. It's large compared to our solar system. It's large compared to our lives. But compared to the distances between galaxies, it's minuscule. A single bright fleck floating in a vast black sea. The gulf between the Milky Way and its nearest neighbors is tens of times greater than the galaxy's entire diameter. Our spiral home, massive as it seems, could line up hundreds of times across the space separating it from another galaxy, and there would still be darkness left over. This redefines what large truly means. In the universe, there is no fixed sense of scale. Everything we think of as enormous eventually becomes small when compared to something greater. Mountains seem huge until we see planets. Planets seem vast until we consider stars. Stars seem infinite until we think of galaxies. And galaxies, too, even mighty ones like the Milky Way, are dwarfed by the chasms of space that stretch between them. Every time we expand our view, what once felt infinite becomes fragile and fleeting. This is one of the most profound truths of the cosmos. Scale is relative and perspective is everything. The Milky Way, majestic though it is, occupies an almost laughably small volume of the observable universe. Its 100,000 light-years of glory fade into nothing when set against the billions of light-years that span the cosmos. The idea of large collapses in the face of cosmic architecture. Our galaxy is not the cathedral of the universe we once believed. It's just one brick in an endless wall. And as we widen our vision even more, we discover that the Milky Way is not alone in this immensity. It's surrounded by neighbors. Galaxies like Andromeda, Triangulum, and dozens of smaller companions, drifting together through the void bound by a common gravitational fate. They form a small cluster, a local gathering in the otherwise desolate dark. These are our galactic neighbors. The next step outward on our journey of perspective. Just beyond the faint outer edges of the Milky Way's spiral arms, past the drifting clouds of gas and the last scattering of stars that mark our galactic borders, lies a darkness that is not truly empty. For hidden within that void are other galaxies, each one a colossal city of stars in its own right. To the unaided human eye, the universe beyond the Milky Way seems still and silent, but through a telescope, that darkness transforms into a living landscape of galaxies, vast and diverse, spinning, colliding, evolving. A reminder that our home, magnificent as it may seem, is just one among countless others. The most famous of these neighboring galaxies is the Andromeda Galaxy, also known as M31. It is the closest spiral galaxy to us, a colossal mirror to our own, sitting approximately 2.5 million light-years away. Even from that mind-bending distance, Andromeda is visible to the naked eye on clear nights, appearing as a faint, ghostly smudge in the constellation of the same name. That faint glow is the combined light of over 1 trillion stars, all blending together across the abyss of space. Andromeda is larger than the Milky Way in nearly every way, but much wider, heavier, and home to roughly twice as many stars. If our galaxy were a great wheel of light, Andromeda would be a brighter, broader one turning beside it, slowly drifting toward us through the intergalactic dark. Andromeda's size and majesty remind us that the Milky Way, for all its grandeur, is not exceptional. It is not the centerpiece of the cosmos. In fact, it is quite average. One spiral among billions, neither the largest nor the smallest, neither the oldest nor the youngest. Andromeda's spiral arms stretch nearly 220,000 light-years across, more than twice the width of our own galaxy. Within its glowing disk, stars are born and die in endless cycles, planets spin around suns we will never see, and black holes lurk at its core and in its outskirts, consuming matter in silent eruptions of energy. For every wonder we've ever imagined about our galaxy, Andromeda mirrors it, perhaps even surpasses it. And yet it, too, is only one of many. The Triangulum Galaxy, also known as M33, is another neighbor. Smaller, fainter, and farther away, yet still vast beyond comprehension. It lies about 3 million light-years from us and is the third largest member of our galactic neighborhood. Triangulum is often described as a miniature spiral galaxy, but that term is deceiving. Its diameter still stretches some 60,000 light-years, and it contains tens of billions of stars. To human minds accustomed to thinking in kilometers and miles, that number defies imagination. Triangulum, though smaller than the Milky Way, would still engulf everything we know. Everything in our entire solar system, and every star we see in the night sky. Thousands of times over. When astronomers look at these neighboring galaxies through powerful telescopes, they see not isolated systems, but family members connected by invisible threads of gravity and dark matter. Together, Andromeda, the Milky Way, and Triangulum are the three major galaxies that dominate our corner of the cosmos. Surrounding them are dozens of smaller dwarf galaxies, dim, irregular clusters of stars that orbit like satellites around their massive parents. Some of these dwarfs are so faint that they were only discovered in the last few decades. The Large and Small Magellanic Clouds, visible from the southern hemisphere, are two such companions to the Milky Way. Distorted and stretched by its gravitational pull, slowly being drawn closer over cosmic time. These galaxies form what astronomers call a local ecosystem in the universe, a dynamic network of gravitational relationships, collisions, and mergers that have been unfolding for billions of years. The Milky Way itself has a violent history of consuming smaller galaxies. Astronomers can trace faint stellar streams to remnants of devoured neighbors that arc around its halo like ghostly scars. Even as we speak, the Milky Way and Andromeda are inching toward each other at roughly 110 kilometers per second, destined to collide in about 4 billion years. When that happens, their spiral structures will merge and twist, flinging stars into new orbits and creating a single massive elliptical galaxy that astronomers have nicknamed Milkomeda. That eventual union is not an anomaly. It's part of the cosmic dance that all galaxies share. Across the universe, galaxies collide and merge in an endless cycle of creation and destruction. The Milky Way is not unique in this. Its spiral shape, its clusters of stars, its central black hole, these are all features repeated again and again in galaxies of every size and kind. For every Milky Way, there are countless others who just like it. Barred spirals, elliptical giants, dwarf irregulars, and more exotic forms shaped by the forces of time and gravity. Our galaxy may feel singular to us because it is home, but in the universe, it is utterly ordinary. What makes this realization even more staggering is how close our neighbors are by cosmic standards, and yet how unreachable they remain. The light from Andromeda that we see tonight left its galaxy 2.5 million years ago, long before the first humans existed. Every glimpse we take of it is a look into the ancient past, a photograph of a moment that ended long before civilization began. The light from Triangulum is even older, and beyond those, further out in space are billions more galaxies, each one receding faster and farther away as the universe expands. The distances grow so immense that even light, the universal messenger, struggles to keep pace. To understand how small the Milky Way is, imagine shrinking the entire galaxy down to the size of a coin. In that same scale, Andromeda would be another coin sitting about 2.5 meters away, but beyond those two coins in every direction would be billions more, stretching on endlessly, filling a cosmic room so large we could never see its farthest walls. Our galaxy, in that sense, is not even a dominant feature. It is one among a vast cosmic crowd, one spiral in an incomprehensible multitude. This understanding dismantles the old belief that our galaxy, or our planet, holds a special place in the cosmos. For centuries, humanity imagined itself at the center of creation. Then, as our knowledge grew, we moved outward, first realizing Earth orbits the Sun, then that the Sun orbits the Milky Way's center, and now that the Milky Way itself is just one of billions of galaxies scattered across the universe. Each step in that journey has humbled us, stripping away illusions of centrality and revealing a deeper truth. We are not the center of the story, but part of a vast and ancient tapestry woven from stars. And still, this tapestry expands. The space between galaxies stretches as the universe grows, carrying them farther apart with every passing moment. The light we see from the nearest galaxies is ancient, but the light from the farthest ones has been stretched, reddened, and dimmed by the expanding fabric of space-time itself. The Milky Way and its neighbors form only a tiny local cluster within this ever-growing universe. a small gathering of galaxies drifting together in the boundless dark. It's within this context that we begin to truly grasp our place, not as inhabitants of a grand solitary galaxy, but as residents of a small interconnected community of galaxies, a cosmic neighborhood. Each galaxy in this cluster is a world unto itself, filled with its own mysteries, histories, and wonders, yet together they form just one small corner of something even larger. A collection known as the local group, a region that binds our galaxy and its neighbors in a shared gravitational embrace. And as vast as the local group is, even it will soon seem small. When we step back far enough to see not just the Milky Way, not just Andromeda or Triangulum, but the larger structure they belong to, we discover whatever that our galaxy is part of a modest family. A gravitationally bound community of galaxies known as the local group. It's our small neighborhood in the cosmic city, a place where galaxies drift together through the black expanse, held loosely by the invisible glue of gravity. While this might sound grand, in cosmic terms, the local group is a tiny gathering, only about 10 million light-years across, a mere speck compared to the vast superclusters that lace the universe together. Within this relatively compact region are around 80 known galaxies, though most of them are small, dim, and irregular in shape. Cosmic minnows swimming alongside a few much larger whales. At the heart of this cluster lie its two giants, the Milky Way and the Andromeda Galaxy, M31. They dominate the local group, their combined mass making up the lion's share of its gravitational pull. Between them lies a vast gulf of space, 2.5 million light-years wide, across which they slowly inch toward one another. Over billions of years, their mutual gravity has drawn them into a slow, silent embrace that will eventually end in collision, a cosmic destiny written in the very fabric of their motion. But while the Milky Way is magnificent, it's not the dominant force here. In fact, Andromeda is the true heavyweight of the local group. It's larger, more massive, and contains roughly twice as many stars. If our local group were a small town, the Milky Way would be a thriving suburb. Impressive, yes, but still second to the bright city skyline of Andromeda. This is a humbling realization. Even in our own cosmic backyard, we are not the biggest, brightest, or most significant structure. We orbit, we spin, we shine, but there are neighbors nearby that outshine us in every measurable way. The third most prominent member of this galactic family is the Triangulum Galaxy, M33, which we've already met. Smaller than both the Milky Way and Andromeda, but still grand by any standard, containing tens of billions of stars. Some astronomers speculate that Triangulum might be a satellite of Andromeda, orbiting it much like the smaller galaxies orbit the Milky Way. Beyond these three major players, the rest of the local group is populated by dwarf galaxies, tiny irregular collections of stars, many of which are faint enough to have gone unnoticed until recent decades. Among these dwarfs are the Magellanic Clouds, two small galaxies that can be seen with the naked eye from the southern hemisphere. They are the Milky Way's closest companions, gravitationally tethered to us, slowly being stretched and distorted by our galaxy's immense pull. Others, like the Sagittarius Dwarf and the Canis Major Dwarf, are so close that they are in the process of being absorbed into the Milky Way itself, their stars being pulled apart and scattered through our galactic halo like threads unraveling in the dark. The local group itself is not organized in any rigid or symmetrical way. It's more like a loose association, a gravitational gathering where galaxies orbit one another in slow, complex patterns. There is no single center, no clear boundary. Instead, the entire cluster is held together by the combined gravitational influence of its largest galaxies, surrounded by the faint glow of smaller ones that drift in their orbits. If you could step back and look at the local group from afar, it would resemble a scattering of light across a black canvas, two brilliant spirals shining at the center, surrounded by a faint halo of smaller, dimmer companions. What's particularly fascinating about the local group is that, despite its apparent smallness, it represents an important piece of cosmic structure. It's one of the countless building blocks that make up the vast network of the universe. Each local cluster linking to others through the invisible filaments of gravity and dark matter. The local group itself lies on the outskirts of the Virgo Supercluster, like a small suburb clinging to the edge of a sprawling city. In that greater structure, Our local group plays no central role. It's just one small node in the cosmic web. And even within that node, our Milky Way is only the second largest participant. Still, it's remarkable how much activity and complexity can exist within this tiny portion of the cosmos. The Milky Way, Andromeda, and their smaller companions are in constant motion, orbiting one another in a slow, choreographed dance that has been unfolding for billions of years. Streams of stars torn from smaller galaxies arc through intergalactic space. Gas and dust drift between them, sometimes forming bridges of material that hint at ancient collisions or gravitational tugs. This is not a static neighborhood. It's a living, changing environment, shaped by the invisible hands of gravity and time. And while the local group is small compared to the universe at large, even its 10 million light-year span is beyond anything we can truly imagine. To cross from one end to the other at the speed of light would take 10 million years, more than twice as long as the entire history of humanity. That's the scale of our local region, and the word local becomes almost absurd at such magnitudes. Yet in the universe's incomprehensible hierarchy, the local group is indeed small, just one of millions of such clusters scattered throughout the observable cosmos. It's a cosmic irony that we call it local at all. To beings bound to a single planet, even the space between the moon and Earth feels vast. But to the universe, 10 million light-years is nothing more than a cosmic neighborhood. One block in an infinite city. Within it, our Milky Way shines as a modest tenant, its spiral arms swirling quietly in the dark, its billions of stars a fraction of the total light that fills this cluster. And as humbling as that is, the local group itself is only a beginning. Because when we step even farther back, we find that this small galactic family, this cluster of galaxies drifting through the void, is part of something vastly greater. It belongs to an enormous congregation of clusters and superclusters that extend across hundreds of millions of light years. And within that larger structure, our entire local group, Andromeda, the Milky Way, all its stars, all its planets, all its histories, becomes almost invisible. We are about to step into that realm now. To look at the colossal structures that make even the local group seem microscopic. If the local group were a cosmic neighborhood, a cluster of shining cities scattered through the night, then the Andromeda galaxy would be its grand metropolis, towering over the rest. Where the Milky Way glows with stately beauty, Andromeda blazes with overwhelming brilliance. It outshines us in nearly every measurable way. It's larger, heavier, brighter, and richer in stars. And though it lies an astonishing 2.5 million light-years away, it is so vast that on clear dark nights, it can be seen with the naked eye. A faint, hazy oval of light, the combined glow of over 1 trillion suns whispering across intergalactic space. That faint glow is a message from a greater world, one that in every way makes our Milky Way look humble by comparison. While our own galaxy stretches about 100,000 light-years across, Andromeda spans nearly 220,000, more than twice as wide. Its sweeping spiral arms arc gracefully through the void, packed with luminous stars, clusters, and nebulae. Its central bulge glows intensely, home to older stars and an even more massive supermassive black hole than our own Sagittarius A. The total mass of Andromeda, counting both visible matter and the mysterious dark matter that surrounds it, may be double that of the Milky Way, making it the largest galaxy in the universe, dominant member of our local group. The sheer number of stars inside Andromeda is staggering. Where the Milky Way may contain between 200 and 400 billion, Andromeda likely holds 1 trillion or more. Think about that number. 1 trillion stars, each potentially hosting its own planets, moons, and stories. Even if only a fraction of those stars had habitable worlds, there could be billions of planets within Andromeda alone capable of supporting life as we know it. And yet, to us, that entire galaxy appears as nothing more than a soft patch of light, smaller than your fingertip held up against the sky. The scale of that difference between perception and reality defies imagination. In many ways, Andromeda is a cosmic mirror, both similar and strikingly different from the Milky Way. Like our galaxy, it's a barred spiral with beautiful arms that wind outward from a bright core. Both galaxies are rich in gas and dust, teeming with regions of active star formation. But Andromeda's arms are thicker, its disk broader, and its structure more defined. It contains over 400 known globular clusters, dense swarms of ancient stars orbiting far from the galactic center, compared to the Milky Way's roughly 150. These clusters act as stellar fossils, preserving the history of Andromeda's formation and the many collisions it has endured. In fact, Andromeda's size and brightness are the result of a long history of galactic cannibalism. It has devoured smaller galaxies, absorbing their stars and expanding its reach across space. Our Milky Way has done the same, of course, but on a smaller scale. Both galaxies bear the scars of these ancient feasts, faint streams of stars stretching through their halos, the remains of once independent galaxies now subsumed into something larger. But while both have grown through cosmic mergers, Andromeda has simply eaten more. It's the product of a more voracious history, a survivor that has risen to dominance through billions of years of gravitational conquest. Astronomers believe that Andromeda and the Milky Way are now locked in a slow, inevitable collision course. Though separated by 2.5 million light-years, the two galaxies are drifting toward each other at roughly 110 kilometers per second, or about 250,000 miles per hour. That sounds fast, but space is so vast that it will take around 4 billion years before their disks finally collide. When they do, neither galaxy will survive in its current form. Their beautiful spirals will twist and stretch, stars will be flung into the new orbits, and over the course of another few billion years, they will merge into a single enormous elliptical galaxy. One that astronomers have dubbed Milkomeda, or Milkdromeda. It's a strange and beautiful thought. Our galaxy's ultimate fate is to merge with its brighter, larger neighbor, becoming something new in the process. But for now, the two remain distinct, distant companions gliding toward each other across the cosmic sea. The gravitational dance between them has already begun. Astronomers can see subtle tidal distortions at the edges of both galaxies, faint hints of the pull each exerts on the other. Even though they are separated by millions of light years, their mutual gravity binds them in an invisible embrace. And yet, despite its dominance, Andromeda is not an anomaly. It's not some cosmic giant that stands alone in its might. Across the universe, there are countless galaxies even larger, sprawling elliptical galaxies that contain not just trillions, but tens of trillions of stars, some stretching 500,000 light-years or more across. Compared to these true titans, even Andromeda is modest. What makes our local group special, then, isn't its size. It's its intimacy. We can see Andromeda, we can photograph it, we can measure it. It's our nearest galactic neighbor, and in its luminous spiral we glimpse the vastness of the universe reflected back at us. The Milky Way and Andromeda are twin beacons in the small patch of the cosmos, siblings born from the same universal process of gravity and time, destined to reunite in a cataclysmic embrace. But in this pairing, we are not the elder nor the stronger. The Milky Way, magnificent as it is, plays second fiddle to the grander Andromeda. And that truth is humbling. Even within our small corner of existence, we are reminded that greatness is relative. Our galaxy, which feels infinite from within, is outshone by its nearest neighbor. And beyond Andromeda, even greater structures await, because as vast as these two spiral titans are, they are not isolated. They belong to something larger still, a gravitational domain that stretches far beyond the local group's modest bounds. For if we step back yet again, we'll find that these two grand galaxies, locked in their slow-motion collision, are merely part of a sprawling galactic landscape that extends for hundreds of millions of light-years. A supercluster of unimaginable scale. The local group, with all its majesty, is only a drop in that boundless ocean. If the local group is our galactic neighborhood, a small cluster of families gathered close together in the vast darkness, then the Virgo Supercluster is our cosmic city. It's the next grand step outward in scale, an immense gravitational congregation that binds together thousands upon thousands of galaxies, each one a glowing island of stars adrift in the endless night. And within that staggering expanse, spanning more than 110 million light-years across, Our entire local group, with all its beauty, all its stars, and all its history, amounts to little more than a single tiny district, an almost invisible speck lost in a vast galactic metropolis. To begin to grasp the enormity of the Virgo Supercluster, imagine for a moment what it contains. Astronomers estimate that it holds more than 2,000 individual galaxies, possibly far more. Spirals, ellipticals, dwarfs, irregulars, and everything in between. Each of those galaxies contains hundreds of billions of stars, and many of those stars are orbited by planets, moons, and worlds beyond our comprehension. It is a cosmic structure of nearly incomprehensible richness. A grand celestial tapestry stretching across hundreds of millions of light years. At its heart lies the Virgo cluster, a dense swarm of over 1,500 galaxies centered around the constellation Virgo, roughly 54 million light-years away from us. This cluster alone is a gravitational giant, containing some of the most massive galaxies ever observed. Its core is dominated by enormous elliptical galaxies, such as Messier 87, M87, a truly colossal structure that dwarfs our Milky Way. M87 contains several trillion stars and is home to a supermassive black hole more than 6 billion times the mass of the Sun. The very black hole captured in the first ever direct photograph in 2019. Compared to M87, even mighty Andromeda looks like a delicate spiral toy adrift beside a cosmic leviathan. The local group, by contrast, resides far from this crowded center, on the outskirts of the Virgo Supercluster, the cosmic equivalent of living in a quiet suburb at the edge of a bustling galactic metropolis. Our group is gravitationally connected to the Virgo cluster, slowly drifting toward it, though at such a distance that the journey would take tens of billions of years, even if we could travel at light speed. We are part of its outermost realm, bound not by proximity, but by the faint but unbreakable threads of gravity that link all things across cosmic space. When astronomers first realized that galaxies themselves cluster together into such vast structures, it was one of the great paradigm shifts in human understanding. For centuries, humanity believed the Milky Way was the entire universe. Then we learned it was just one galaxy among many. And now we know that even galaxies themselves are not solitary wanderers. They gather into clusters, and those clusters weave together into superclusters, forming the largest coherent structures in the observable cosmos. The Virgo Supercluster is our own vast home within that hierarchy. And yet, even it is not the final step outward. The scale of the Virgo Supercluster is almost impossible to describe in familiar terms. It stretches across more than 100 million light-years of space, and its total mass is estimated to be over 10 to the 15th power times the mass of the Sun, a number so large it almost loses meaning. To put it into perspective, if the Milky Way were reduced to the size of a single grain of sand, the Virgo Supercluster would be a region of space over a mile wide filled with thousands of such grains, each one glowing faintly in the dark. And even that analogy falls short, because the actual distance between galaxies, even in such a cluster, are so vast that they can only be measured in the units of light itself. What's even more astonishing is that the Virgo Supercluster is not static. It's in motion, expanding, evolving, and interacting with other nearby clusters through the pull of gravity. Space itself is stretching, driven by the mysterious force we call dark energy, and yet local regions like the Virgo Supercluster remain gravitationally bound, holding together despite the universe's expansion. Inside this gravitationally connected web, galaxies swirl, collide, and merge in an eternal cosmic dance. Our own local group, though it is near the edge, participates in this dance as one of its most distant but still loyal members. And yet, for all its grandeur, the Virgo Supercluster is only a small part of an even larger cosmic pattern. For centuries, we thought superclusters might be the universe's grandest structures, the final layer of organization before the infinite void. But modern observations have revealed something even more breathtaking. Superclusters themselves are only nodes in an even greater cosmic web, vast filaments of galaxies and dark matter that stretch for billions of light years, connecting clusters and superclusters into the immense architecture of the universe. To understand how small we are, consider this. The local group, with its 80 galaxies and 2 great spirals, would be invisible if we tried to map the Virgo Supercluster as a whole. It would be a dot too faint to distinguish. Like a single spark in a sea of fire, and the Milky Way, that glowing river of stars that fills our sky, would vanish entirely. It would become less than a dust mote in this cosmic city of galaxies. Every star we've ever seen, every world we've ever imagined, every trace of our existence would be contained within that dust mote. One grain among billions, drifting quietly in the grand cluster's outer reaches. What's humbling, and strangely beautiful, is that we can even know this. From our small blue planet, orbiting an unremarkable star, we have learned to see the structure of the cosmos across unimaginable distances. We have measured the light of galaxies millions of light years away, mapped their motions, and traced their connections. And in doing so, we've discovered that the Milky Way, once thought infinite, is part of a structure so immense that even calling it large feels inadequate. The Virgo Supercluster dwarfs everything we can see with our eyes, and yet it too is not the largest thing that exists, because beyond it lies something even greater. A superstructure so vast that it binds not just our Virgo Supercluster, but dozens of others into one colossal region of space, a true cosmic continent. This is our true home in the universe, one that stretches not for millions, but for hundreds of millions of light years. It is the grand stage upon which the Virgo Supercluster itself is only a tiny act. It's called Laniakea, and it is here among its sweeping filaments of light and gravity that the Milky Way truly finds its place. When astronomers finally mapped the structure of the Virgo Supercluster in the mid-2000s, something extraordinary emerged from the data. A revelation that shattered even our loftiest notions of scale. The Virgo Supercluster, vast and magnificent as it is, turned out not to be an isolated island of galaxies. It was just one small tributary in an even grander cosmic river. A sprawling, interconnected region of space that binds together thousands of superclusters into a single unified whole. This greater domain is called Laniakea, a word from the Hawaiian language that translates to immense heaven. It is the true home of our galaxy, our address in the deep cosmic web. Laniakea is staggering in every sense of the word. It stretches across more than 500 million light years, encompassing roughly 100,000 galaxies spread throughout a volume so vast that light, traveling at its relentless 300,000 kilometers per second, would take 500 million years to traverse it. This is not merely a collection of galaxies, but a continent of cosmic proportions, a gravitational landscape of unimaginable size and complexity. Within its boundaries lies not just the Virgo Supercluster, but many others as well. Hydra Centaurus, Pavo Indus, Fornax, Norma, and more, each one a colossal structure in its own right, each containing thousands of galaxies and trillions upon trillions of stars. To imagine the scale of Laniakea is to stretch human comprehension to its breaking point. Picture every galaxy as a grain of sand. Then imagine a sphere 500 million light-years wide, filled with those grains, each glowing faintly, each the home of billions of suns and worlds. That is Laniakea. It is not a rigid object, but a cosmic flow, a region defined by the motion of galaxies as they fall together under the pull of gravity. Every galaxy within its bounds, including our Milky Way, moves like a drop of water in an enormous gravitational current, slowly drifting toward a central attractor, a point known as the Great Attractor, some 250 million light-years away. The Great Attractor is not a single object, but rather a vast gravitational anomaly, a dense region of space where the combined mass of galaxies, dark matter, and possibly other unknown forces draw everything around it inward. Galaxies from all directions, including ours, are slowly streaming toward this unseen nexus. It is as though the universe itself is shaped by invisible rivers, and Laniakea is one of the grandest of them all. The Milky Way, the Andromeda Galaxy, the Virgo Cluster, and thousands more are all being carried along in that immense cosmic current, pulled through the universe like leaves drifting on a cosmic tide. And yet, even within this enormous region, our galaxy's contribution is infinitesimal. The Milky Way, that sprawling 100,000 light-year spiral, becomes, in the scale of Laniakea, less than a pinprick of light. To put it in perspective, if Laniakea were scaled down to the size of Earth, the entire Milky Way would be smaller than a bacterium floating on its surface. Our entire local group, short to every galaxy we have ever mapped or measured, would be smaller still, an invisible speck drifting within that microscopic point. The sheer disproportion is beyond metaphor. Words like large or small cease to have meaning. The discovery of Laniakea was not just a triumph of astronomy, it was a revelation about how the universe is organized. For centuries, we have thought of galaxies as the universe's primary building blocks. Then we learned they form clusters, and those clusters form superclusters. But now we see that even superclusters are not isolated. They are connected, woven into vast filaments that stretch across the universe like threads in a cosmic web. Laniakea is one of these threads, one strand in a tapestry of unimaginable scale. Its borders are defined not by physical edges, but by motion. By the way galaxies flow through space. It is the gravitational basin in which we and everything we know reside. In this sense, Laniakea is not merely our location in the universe, it's our cosmic ecosystem. Every atom in our bodies, every photon of starlight, every world ever imagined belongs to this immense gravitational realm. We are residents of a continent made not of rock and ocean, but of galaxies and dark matter. When you look up at the Milky Way in the night sky, you are seeing one city in this cosmic continent, one luminous district in an empire of light that stretches for 500 million light-years in every direction. The scale of Laniakea challenges not only our imagination but our sense of significance. Our galaxy, which once seemed infinite, now fits comfortably within something so vast that it defies the very concept of containment. The Virgo Supercluster, once thought to be our ultimate cosmic boundary, becomes just one province in a larger structure whose full extent we are only beginning to understand. And even that, humbling as it is, still does not represent the entirety of creation. Beyond the borders of Laniakea lie other superclusters, equally immense regions like Perseus Pisces, Hercules, and Coma, each its own continent in the endless cosmic web. If we could step outside of everything and look back, if we could somehow view Laniakea from a vantage point hundreds of billions of light years away, it would appear as a faint glowing filament stretching across the blackness, just one of many threads woven through the grand structure of the universe. Its edges would blur and merge with neighboring filaments, forming an intricate network that looks almost biological, like the neural web of a vast cosmic mind. The galaxies would appear like sparks in those threads, points of light marking the places where matter, time, and energy converge. And there, barely noticeable in that grand view, would be our Milky Way, a single spark among 100,000 others, nestled in the outer reaches of Laniakea, quietly orbiting its place in an infinite pattern. Our solar system, our world, our lives, all of it contained within a fraction of this immeasurable whole. The realization is overwhelming, but it is also awe-inspiring. For to exist here, within such grandeur, is to be part of something vast beyond measure, to share in the universe's greatest architecture. Laniakea is our true cosmic home. But even this mighty realm, 500 million light-years across and home to 100,000 galaxies, is not the final frontier of scale. Because Laniakea itself, as enormous as it seems, is only one filament in a structure that spans billions of light-years. The universe, it turns out, is not a collection of isolated islands at all, but a boundless web of interconnected clusters and voids. And within that web, our galaxy, our Milky Way, our tiny thread of stars, fades to near nothingness. Within the breathtaking immensity of Laniakea, our Milky Way is reduced to almost nothing. One among roughly 100,000 galaxies drifting quietly in an unfathomable sea of light. Each of those galaxies is its own island universe, each containing hundreds of billions of stars, countless planets, and possibly untold forms of life. And yet, within this vast cosmic continent of galaxies, the Milky Way is no more remarkable than a single grain of sand on an endless beach. When we imagine 100,000 galaxies, our minds instinctively reach for patterns, clusters of light, dense regions of brilliance. But even that visualization fails to convey the truth. Each galaxy within Laniakea is separated by millions of light-years of near-perfect emptiness. If the Milky Way were a coin, its nearest neighbor might be another coin placed dozens or hundreds of meters away, and beyond that, thousands more scattered across an area the size of Earth itself. That's how sparsely galaxies are distributed, even within this colossal structure. Laniakea is not a solid object, but a cosmic architecture of vast emptiness punctuated by islands of light, a delicate filigreed web of gravity binding together regions of unimaginable distance. In this great expanse, our galaxy occupies a small, quiet corner, far from the gravitational heart of Laniakea. The Milky Way lies on one of its outer filaments, a peripheral strand extending like an arm from the dense galactic core near the Great Attractor. We are not near the center of anything. Not the center of our galaxy, not the center of our local group, and certainly not the center of Laniakea. We exist on the outskirts of everything, a tiny whirlpool of stars swirling in the outer reaches of a cosmic river that flows into deeper, denser regions of the universe. The sheer number of galaxies in Laniakea defies comprehension. 100,000 galaxies, each with hundreds of billions of stars. That's on the order of 10 to the 17th stars, a number so vast it exceeds every grain of sand on every beach on Earth. And around those stars may orbit billions upon billions of planets, each with its own possibilities. Some barren and frozen, others cloaked in storms and oceans, perhaps a few with skies under which intelligent eyes look up and wonder, just as we do, about their place in this endless structure. Yet even if life abounds, the distances between galaxies are so enormous that the civilizations within them, if they exist, will almost certainly remain forever strangers, their light unable to bridge the infinite darkness that separates one island from another. It's almost poetic. Within the cosmic continent of Laniakea, each galaxy is a solitary light in a night that will never be fully shared. The Milky Way's glow, bright and vibrant to us, fades to a whisper against the backdrop of so many others. To an observer from a distant galaxy elsewhere in Laniakea, our home would appear as nothing more than a faint speck of light, indistinguishable from the countless other galaxies scattered through the structure. It would not stand out. It would not command attention. It would simply exist, one more ripple in the oceanic flow of cosmic time. And yet that faint, unassuming galaxy, our Milky Way, contains everything we have ever known. Every story, every discovery, every dream humanity has ever had unfolds within a single spiral arm of this one galaxy. When we look outward and realize that there are 100,000 others just like it in Laniakea alone, the mind quivers under the weight of that revelation. Our galaxy, once thought infinite, becomes a single heartbeat in a cosmic organism whose size and complexity transcend imagination. To put this into perspective, if all of Laniakea were represented by the surface of a continent, the Milky Way would be no larger than a single grain of dust lying somewhere on its edge. You could sweep a hand across that continent, and our entire galaxy, the stars, the planets, the sun, and the fragile blue dot of Earth, would vanish beneath your fingertip. The local group, that family of galaxies we once called our neighborhood, would disappear entirely. In the grand topography of Laniakea, we are microscopic, a detail within a detail, a whisper within an eternal roar. What's most humbling is how unexceptional our galaxy is among the 100,000 that share this cosmic continent. Many are larger, brighter, more active, home to supermassive black holes that tear space itself apart, or galaxies colliding in spectacular bursts of star formation. Others are quieter, dimmer, fading into the cosmic background as they exhaust their fuel. The Milky Way, by comparison, is a middleweight, a spiral galaxy in its middle age, still forming stars but no longer young, still luminous but not the brightest, vast but not the greatest. In Laniakea's immeasurable scale, we are simply one of the crowd. Yet even in our ordinariness, there is a strange kind of beauty. To exist within such enormity, to know it, to study it, to name it, is to be part of something extraordinary. We are small, yes, but we are aware of that smallness. The universe, through us, has learned to perceive itself. From one spiral galaxy among 100,000 in Laniakea, a single species on a small planet has opened its eyes and seen the structure of the cosmos. We are not large, but we are luminous in our awareness. Still, the humbling perspective continues to expand. Because Laniakea, as immense as it is not the entire picture. Beyond its filaments stretch other regions, other superclusters, other flows of galaxies. all connected in a vast cosmic web that spans the entire observable universe. In that web, Laniakea itself is only one of countless strands, and the Milky Way, our home, fades into near invisibility. The scale leaps once again beyond imagination, and even this continent of galaxies becomes a mere province in a cosmic empire beyond comprehension. As we pull back still further, we begin to see that the grand architecture of the universe is not a random scattering of galaxies, but a vast interconnected network of light and emptiness, the cosmic web, in which every galaxy, every cluster, every supercluster is bound by invisible threads of gravity and dark matter. It is there at this unimaginable scale that the Milky Way finally disappears entirely, absorbed into the glowing fabric of existence itself. When astronomers first began mapping the positions of galaxies on a truly vast scale, not hundreds or thousands of light years, but hundreds of millions, something astonishing began to appear. The universe, once imagined as a uniform sea of scattered galaxies, revealed an intricate architecture, a hidden order woven into the deep fabric of space. The galaxies weren't distributed randomly at all. They gathered along enormous filaments, forming vast interconnected structures that stretch across billions of light years, while between those filaments lie immense voids, nearly empty expanses of nothingness. This colossal structure, delicate, interconnected, and incomprehensibly large, is known as the cosmic web, the grandest pattern in existence. Laniakea, the immense galactic continent we call home, is just one luminous thread in this unimaginable network. It's not an isolated entity drifting in the void. It's part of a continuous structure of filaments and clusters that link together like the neurons of a cosmic brain. Each filament is composed of billions of galaxies, strung together by gravity and the mysterious scaffolding of dark matter, which forms the invisible backbone of the cosmos. These filaments weave across the observable universe, intersecting at dense knots where galaxy clusters gather, the gravitational hubs of creation, and separating vast, empty regions where almost no matter exists at all. To understand the cosmic web is to grasp the true scale of everything. Picture a sphere roughly 93 billion light-years in diameter, the size of the observable universe. Within that sphere, the galaxies are arranged not like stars sprinkled randomly through space, but more like threads of silk, forming patterns that resemble the branching veins of a leaf or the tendrils of a living organism. Each filament can stretch for hundreds of millions of light-years, containing thousands of clusters and superclusters, each one home to countless galaxies. And in between those filaments lie cosmic voids, vast black bubbles where the density of matter is almost zero, where even light seems reluctant to travel. In this enormous three-dimensional lattice, Laniakea is just one filament among billions. It connects to other regions, the Perseus-Pisces supercluster, the Shapley supercluster, the Coma Wall, all of them linked through vast gravitational bridges of matter and dark energy. The cosmic web, taken as a whole, forms the skeleton of the universe. It is the grand design upon which everything else, galaxies, stars, planets, life, depends. Its filaments are where the matter of the universe condensed after the Big Bang, drawn together by the invisible hand of gravity, while the voids between them expanded and emptied over cosmic time. It is, in every sense, the architecture of existence. And within this architecture, our Milky Way vanishes almost entirely. If we were to visualize the cosmic web at full scale, then every filament, every cluster, every thread, the Milky Way would not be a visible feature. It would be smaller than a pixel, lost within a single cluster among thousands. Even Laniakea itself, immense beyond human comprehension, would barely register as a small glowing spot in a filament that stretches for hundreds of millions of light years. From this perspective, our galaxy is not just small, it is effectively invisible, a whisper of light in an ocean of brilliance. To fully comprehend this is to confront the limits of imagination. The cosmic web is not a metaphor. It is real. It is a measurable structure that defines the distribution of galaxies in every direction. Through instruments like the Sloan Digital Sky Survey and space telescopes that measure cosmic background radiation, astronomers have mapped portions of this web, revealing its filamentary nature. When you look at those maps, glowing strands against the darkness, it is impossible not to see something almost biological, as though the universe itself is alive with structure and connectivity. The filaments stretch and curve, forming something akin to cosmic rivers, with galaxies flowing along them like currents of light, and it is all connected. Every cluster and every galaxy, from the largest elliptical giants to the faintest dwarf systems, participates in this vast network. Even our Milky Way, humble as it is, sits within one of those threads, gravitationally bound to its neighbors, slowly moving along the great current of matter that runs through Laniakea and out toward the greater superclusters beyond. The same forces that hold the stars of our galaxy together also tie our galaxy to others, and those galaxies to entire clusters, and those clusters to the web itself. The universe on its grandest scales is a single structure, unified, continuous, and magnificent beyond description. Yet the distances between these filaments are so immense that communication, travel, or any conceivable contact between galaxies is utterly impossible. Each galaxy, even each supercluster, exists in a kind of isolation, aware only of the gravitational pull of its nearest neighbors. The cosmic web connects everything, but it also imprisons everything. Light can travel from one galaxy to another, but over cosmic time, as the universe continues to expand, even that light will stretch and fade, until one day the filaments themselves will drift apart, and distant clusters will vanish beyond the horizon of visibility. The cosmic web is not just a structure of connection, it is also a map of future solitude. For now, however, we can still see it. The grand design, the cosmic lattice that holds everything together, and it humbles us in a way nothing else can. The Milky Way, that river of stars that fills our night sky, is revealed to be a mere spark in a filament that is itself one among billions. From this scale, everything we have ever known, every history, every dream is not just small. It is ephemeral, almost weightless in the face of such vastness. And yet, within that smallness, something remarkable endures, the awareness that allows us to see it. From a tiny planet and one invisible galaxy, the universe is watching itself and contemplating its own immensity. That is perhaps the most profound truth of all. The cosmic web reminds us that we are not central, not privileged, not large, but we are connected. We are part of a universe that is both infinite in scale and deeply unified in structure. But as vast and luminous as the web may be, it is defined not only by what is there, but by what is not. Between its glowing filaments lie cosmic voids, colossal gulfs of emptiness so profound that they dwarf every galaxy, every cluster, every imagination. And to truly understand how small our galaxy is, we must turn our gaze toward that emptiness, toward the unimaginable silence that stretches between the threads of creation. Between the glowing filaments of the cosmic web, where galaxies gather in magnificent clusters and superclusters, there lies an opposing realm, one defined not by abundance, but by absence. These are the cosmic voids, immense, dark expanses of near total emptiness, stretching for hundreds of millions of light years in every direction. They are the great gulfs between the threads of the universe, the quiet spaces between the symphonies of light. If the filaments of galaxies are the luminous bones of the cosmos, then the voids are its vast, hollow lungs, empty regions where matter is so sparse that entire galaxies could drift for eternity without encountering another. To call these regions empty almost feels inadequate. A typical cosmic void contains on average only a few atoms per cubic meter, far less than the densest regions of intergalactic space. In many of them there are no stars, no planets, no galaxies at all. Only faint traces of dark matter and the thin whisper of cosmic radiation left over from the Big Bang. The largest of these voids, such as the Boötes void, are truly staggering in their dimensions. The Boötes void alone is roughly 330 million light-years across. To put that in perspective, it's so vast that you could fit the entire Milky Way inside it, not once, but millions of times over, and still have room to spare. It's not a single empty sphere, but a vast region of space so barren that for hundreds of millions of years, light could travel through it and never encounter a single galaxy. Astronomers first discovered the Boötes void in the 1980s, when surveys of galaxies revealed a patch of the universe that was mysteriously blank. When its true scale was realized, it defied every expectation. Within a volume that should have contained thousands of galaxies, researchers found barely a handful, about 60 in total, like lonely embers floating in a cold, extinguished hearth. It was a haunting discovery, a reminder that for all the brilliance of the cosmos, most of it is not light but darkness, and the Boötes void is not unique. The universe is filled with these immense cavities, the Eridanus void, the local void, the KBC void, all vast, all empty. The local void, in fact, borders our own Laniakea Supercluster, a silent chasm about 150 million light-years across, that forms one of the outer boundaries of our cosmic home. The Milky Way itself is perched right along its edge, like a single light flickering on the rim of a great abyss. When we look out into the depths of the local void, we are staring into a region of space so desolate that, from our vantage point, it represents the closest thing the universe has to true nothingness. These voids are not static gaps, but integral parts of the universe's grand design. They are the dark counterpoint to the bright filaments of the cosmic web, born from the same forces that shaped everything else. In the earliest moments after the Big Bang, when matter and energy were almost evenly spread throughout the cosmos, tiny fluctuations, minute differences in the density, caused some regions to attract more matter, while others lost it. Over billions of years, gravity amplified those differences. The dense regions grew denser, forming galaxies, clusters, and filaments, while the empty regions were drained, expanding into the massive voids we see today. They are the universe's great negative spaces, carved out by time and gravity like the silent intervals between the beats of a cosmic heart. The sheer emptiness of these voids is almost beyond understanding. If you were somehow able to travel into one, you would leave behind every point of light you know. The stars of the Milky Way would vanish first, then the faint glow of nearby galaxies, until eventually even the background of clustered galaxies would fade. You would drift in a silence so complete that the concept of distance would lose meaning. The nearest galaxy might be hundreds of millions of light years away, and even that faint point of light would be receding. The very fabric of space would feel stretched, thinned, like the air at impossible altitude. It is not a place for life, or for anything that depends on warmth, matter, or light. The voids are the universe's deserts, places where time itself seems to stand still. Yet paradoxically, these immense empty regions are crucial to the universe's structure. Without them, the cosmic web would not exist as it does. The voids provide the contrast, the negative spaces that allows the filaments and clusters to form and evolve. In a sense, the voids define the web. They are the vast, dark oceans in which the islands of galaxies float. Matter flows away from the voids, streaming toward the dense filaments under the influence of gravity, and as it does, the voids themselves slowly grow, becoming even emptier with time. The universe is not static. It's a living geometry in which the bright and the dark, the full and the empty, shape one another across cosmic time. The concept of a void challenges not only our understanding of space, but our sense of presence. When we contemplate a galaxy, we think of creation, stars forming, light shining, gravity weaving patterns of order. But when we contemplate a void, we face the absence of creation, the silence between those symphonies. And yet, even there, the universe is not completely dead. Tiny quantum fluctuations ripple through the darkness. Stray atoms drift endlessly, carrying the faint imprint of cosmic history. Even emptiness, on the largest scales, hums with the subtle energy of existence. Standing at the edge of one of these vast cosmic voids, the Milky Way, our entire galaxy, becomes nothing more than a single flicker of light clinging to the edge of the abyss. Every star we see, every world we've discovered, every fragment of our history floats precariously close to infinite darkness. The voids are a mirror, reflecting back the ultimate truth of scale. That existence itself is rare. Most of the universe is not stars and planets, but empty, silent darkness. We live in the thinnest sliver of matter in an ocean of nothingness. And still we look outward across that emptiness with curiosity and awe. For all the vastness of the voids, we have learned to measure them, to map them, to understand their role in shaping the cosmos. We have stared into the universe's most silent spaces and found beauty there, not in their emptiness, but in their meaning. They remind us that creation is not everywhere, but precious, that light, wherever it exists, shines against an overwhelming darkness. But the scale of these voids, enormous though it may be, is still only one way to measure the vastness of the universe. To truly grasp how small we are, we must turn our attention to the thing that reveals it all to us, light itself, for light is the universe's messenger, the thread that connects every star, every galaxy, every corner of time and space, and by following that light across the cosmos, we begin to see just how vast the journey truly is. Light, that most familiar and fragile thing, the essence of everything we see, is also our ruler of the cosmos. It is the universe's great messenger, the silent traveler that carries to us the stories of distant galaxies, of dying stars and newborn worlds. Every flicker in the night sky, every shimmer from a far-off sun is light that has journeyed through unfathomable distance and time to reach our eyes. It is how we know the universe at all, for in truth we do not see the cosmos as it is, but as it was. In our own Milky Way, light is our first and simplest measure of scale. The galaxy is about 100,000 light-years across, which means a single beam of light, traveling at 300,000 kilometers per second, the fastest speed possible in nature, would take a full 100,000 years to cross from one edge to the other. Imagine that, a ray of light leaving a star at one end of the galaxy would still be traveling long after entire human civilizations had risen and fallen, after ice ages had come and gone, after mountains had eroded and continents had shifted. It would move relentlessly, never stopping, never slowing, until it finally emerged on the far side of the Milky Way, 100 millennia after it began. When we look at the night sky even within our galaxy, we are already looking back in time. The light from the nearest star, Proxima Centauri, takes over 4 years to reach us. The light from the bright star Deneb in the constellation Cygnus has been traveling for roughly 2,600 years. It left its star around the same time that ancient Greece was at its peak. The light from the Orion Nebula, a glowing nursery of new stars, began its journey over 1,300 years ago, before the rise of the medieval world. And when we look toward the galactic center, our eyes receive photons that began their voyage 25,000 years ago, when humans still painted on cave walls and hunted mammoths. Every star we see is a message from the past, a frozen moment, a memory written in light. But if light takes 100,000 years just to cross our galaxy, imagine what happens when we look beyond it. When we peer across the unimaginable voids between galaxies. The nearest large galaxy, Andromeda, lies 2.5 million light-years away. The light we see from it tonight left long before modern humans even existed. It has been traveling since our earliest ancestors first learned to shape tools and control fire. Each time we gaze at Andromeda, we are looking back not just in space, but in time. Seeing the galaxy as it was 2.5 million years ago, when the Earth itself was young in its current age, and yet Andromeda is still close by cosmic standards. The light from more distant galaxies, those lying billions of light-years away, began its journey when the universe itself was in its infancy. Some of the most ancient light we can detect today was emitted over 13 billion years ago, from the first galaxies that ever formed, only a few 100 million years after the Big Bang. That light has been stretching across the cosmos for almost the entire history of time, its wavelengths lengthened and softened by the expansion of the universe, arriving to us now as faint red-shifted whispers from the dawn of creation. When we observe those farthest galaxies, ghostly smudges captured by telescopes like Hubble and James Webb, we are literally seeing back in time to the universe's childhood. Each photon that reaches our instruments is an ancient traveler, older than our sun, older than our galaxy, older even than the heavy elements that make up our bodies. That light began its journey long before the Milky Way took shape, long before stars like ours existed, when the universe was still a sea of hydrogen and helium. And yet, billions of years later, those fragile particles of light still arrive here, still strike our detectors, still tell their story, The distances light crosses are so immense that they stretch our language to its limits. We say light year as though it were just another unit of distances, like kilometers or miles, but a light year, the distance light travels in that 1 year, is nearly 10 trillion kilometers. Even our fastest spacecraft would take tens of thousands of years to cover a single light year, and yet light itself covers that span effortlessly every second of every day. When we speak of galaxies billions of light years away, we are speaking of distance that our minds simply cannot hold. We are describing spaces so vast that the very concept of near or far dissolves into meaninglessness. Light, in a sense, is our only connection to the wider universe. We cannot travel to the stars, we cannot touch the distant galaxies, but their light comes to us. It carries the fingerprint of their atoms, the rhythm of their motion, the color of their temperature, the history of their lives. Through light, we read the universe like an ancient manuscript written across time itself. Each wavelength, each photon is a letter in the story of existence. And we are only beginning to learn how to read it. And that story, revealed by light, tells us something profound about scale. Because as vast as the Milky Way seems, as incomprehensible as 100,000 light years may sound, those distances shrink to insignificance when measured against the billions of light years that light travels across the universe. The farthest galaxies we can see are so distant that their light has been journeying for most of cosmic history, taking billions upon billions of years to arrive. And beyond them, there are likely more galaxies still. Their light so faint or so stretched by the expansion of space that it may never reach us at all. In this way, light reveals both the greatness of the universe and the smallness of our place within it. Every photon that strikes our eyes tonight is a survivor, a traveler from across time, bearing witness to the enormity that surrounds us. And as we measure those journeys, 100,000 years across the Milky Way, billions across the cosmos, and we begin to see that even light itself struggles to cross the distances that define the universe. But there is an even greater scale still, one that pushes beyond even the farthest galaxies our telescopes can see. For light, as vast as its reach is, can only show us so much. The universe extends far beyond the limits of what light has had time to reach us from. That limit defines what we call the observable universe, the boundary of all we can see, all that light has yet revealed. Beyond it lies the unknowable expanse, perhaps infinite, where our galaxy becomes smaller still, vanishing entirely into the unseen. The observable universe. Even the name itself carries a quiet humility. It does not claim to describe everything that exists, only what we are capable of seeing, what light has had time to reach us since the beginning of time. And yet even that limited portion of the cosmos is so vast that it staggers the imagination, leaving words helpless before its scale. The observable universe stretches approximately 93 billion light-years across, a diameter so immense that even light, traveling since the very first moment of creation, has not yet crossed it. Within that immeasurable expanse lie an estimated 2 trillion galaxies, each containing hundreds of billions of stars. Against this overwhelming immensity, our Milky Way, grand as it feels to us, fades into insignificance, a single ordinary spiral lost in a sea of light that stretches beyond comprehension. When astronomers say observable, they refer to the ultimate limit of what we can see, not because there is nothing beyond it, but because light from those farther regions has not yet had time to reach us. The universe is about 13.8 billion years old, and light travels at a finite speed. That means the farthest galaxies we can detect are those whose light began its journey just after the Big Bang. But because the universe has been expanding for all those billions of years, those distant galaxies are now far farther away than 13.8 billion light-years. In fact, they have been carried outward by the stretching fabric of space itself, and today they reside about 46 billion light-years from us in every direction. Thus, the observable universe, the spherical region of space from which light has reached Earth, spans roughly 93 billion light-years in total diameter. That number alone defies any frame of reference we possess. 93 billion light-years means that light, traveling at 300,000 kilometers per second, would take 93 billion years to cross from one edge of visibility to the other, nearly 7 times the age of the universe itself. It's not just large, it's an expanse so profound that it ceases to be describable in human terms. If the Milky Way were shrunk to the size of a grain of sand, then the observable universe would be larger than all the oceans on Earth combined. Vast enough to swallow our galaxy countless times over, until even that grain of sand became undetectable. Within this boundless sphere of observation, the 2 trillion galaxies that populate it form the great tapestry of existence. Each of those galaxies contains hundreds of billions of stars. That means the total number of stars in the observable universe could reach sextillions, a number so large it defies even the counting of imagination. For every star in our galaxy, there are billions of others scattered across space, shining their light into the cosmic dark. And if even a tiny fraction of those stars have planets, and even a fraction of those planets harbor life, then the universe may be teeming with uncountable worlds, each with its own skies, its own suns, its own mysteries. And yet, even among those 2 trillion galaxies, the Milky Way is nothing exceptional. It is not among the largest, nor the smallest. It is not the brightest, nor the dimmest. It is, in almost every way, utterly ordinary. A mid-sized spiral galaxy in a typical region of space. From the perspective of the observable universe, it is simply one among billions of others, indistinguishable from afar. If an observer in a distant galaxy, billions of light years away, could look toward our region of space, the Milky Way would appear as a faint, almost invisible diadem among countless others, one spark in a cosmic sea of fire. To appreciate the enormity of this, consider that our local group, which itself spans 10 million light-years, would be smaller than a subatomic particle if the observable universe were reduced to the size of a single marble. Every galaxy we've ever photographed, Andromeda, Triangulum, the spiraling arms of the Whirlpool Galaxy, the radiant core of Centaurus A, all of them, even combined, would form a mere glimmer within the smallest corner of that marble. The scale is so absurdly large that it almost ceases to be real. Numbers lose meaning, distances dissolve. The mind, stretched to its limit, can only feel awe. And it is awe that defines our encounter with the observable universe. For as much as science can measure and calculate, there remains a fundamental emotional truth to this knowledge. The sheer wonder that we, fragile creatures on a single small planet, can look up and see even a fraction of it. Our telescopes act as time machines, capturing the light that began its journey billions of years ago, from galaxies so far away that their light left them when Earth itself did not yet exist. The farthest galaxies we've seen are faint, red-shifted smudges, their light stretched by the expansion of space into long, invisible wavelengths. Yet even those ghostly remnants speak to us, telling the story of the universe's infancy, a time when galaxies were just forming, when the cosmos was still glowing with the afterlight of its birth. It is humbling, almost heartbreaking, to realize that everything we know and see, the Milky Way, Andromeda, all the galaxies visible in our telescopes, make up only a tiny fraction of this observable universe. The vast majority of galaxies are too distant, too faint, or too obscured for us to ever detect. We can only infer their existence from the faint background glow they contribute to the sky from the gravitational effects they exert on the structure of space. And beyond even those 2 trillion galaxies lies the unknown, regions of space forever beyond our sight, where light has not yet had time to reach us and perhaps never will. The observable universe is, then, a paradox of knowledge, a sphere of understanding surrounded by an ocean of mystery. We know its size, its age, its approximate contents, and yet we know that it's only a small part of something infinitely greater. Beyond the visible horizon, beyond the reach of light itself, there may be countless more galaxies, stretching forever into the unseen. For all we know, the true universe could be hundreds, thousands, or even infinitely larger than the portion we can observe. So even this figure, 93 billion light-years, 2 trillion galaxies, is not a measure of the universe's full size, but of our vision's limit. It is the boundary of our perception, the edge of what light has delivered to us. Beyond that edge, the universe continues. Silent, infinite, eternal. From the vantage point of such immensity, the Milky Way is less than a speck. Our solar system is a mote within that speck, and Earth, our cherished home, is smaller still. A dust mote within the mote, a whisper within the silence. Yet it is from that dust mote that the universe has come to know itself. It is from here, within our tiny galaxy, that we look outward and measure the 93 billion light-year span of all creation. But even the observable universe, vast beyond imagination, is not the end of the story, because what we can see, immense though it seems, is only part of reality. There may be far more beyond it. More galaxies, more clusters, perhaps even other universes entirely hidden forever beyond the horizon of light. To understand that, we must remind ourselves that observable is not the same as everything. It is only the visible surface of something far greater. If the observable universe, the 93 billion light-year-wide sphere that contains everything light has ever revealed, were somehow shrunk down to the size of Earth, then our entire Milky Way galaxy would be smaller than a single speck of dust floating in the air. Not a pebble, not a grain of sand, but an infinitesimal particle, invisible even in a sunbeam. That's how small our home becomes when we compare it directly to the totality of what we can see. And that speck, that almost nothing, contains every star you've ever looked upon, every world that has ever existed, and every story that has ever been told. It's a humbling metaphor, one that collapses all human notions of large into silence. If the observable universe were Earth-sized, then the local group, that cluster of about 80 galaxies we share space with, would be smaller than an atom within that dust mote. Our entire galactic neighborhood, the Milky Way, Andromeda, Triangulum, and their retinue of smaller galaxies, would vanish into invisibility. The Virgo Supercluster, containing thousands of galaxies, would be smaller than a single fiber of that dust speck. A tiny imperfection on an already microscopic point, Laniakea, that immense cosmic continent stretching 500 million light-years across, would not even appear as a blur. It would dissolve entirely, too small to represent on the scale of the Earth-sized universe. In this comparison, the human mind finally breaks. It cannot grasp scales this extreme because our entire existence, our bodies, our world, even our galaxy, occupies the thinnest layer of cosmic insignificance. The numbers are too big, the distances too vast, the ratios too crushing. Every metaphor we can conjure collapses under the weight of reality. A dust speck smaller than a mote represents everything we know. That is the true scale of the Milky Way in context, a ghost particle drifting in an unimaginable expanse. Yet what's most extraordinary about this comparison is that it's not poetic exaggeration. It's literal. The observable universe really does dwarf our galaxy by that much. The Milky Way is about 100,000 light-years across, while the observable universe stretches 93 billion light-years in diameter. That's a difference of almost 1,000,000 to 1 in linear scale. And when you calculate the volume, the disparity becomes mind-melting. The observable universe contains enough space to fit 1 trillion Milky Ways within it. Our galaxy, with its hundreds of billions of stars, is therefore not merely small, it is imperceptible against the immensity of the cosmic total. Even when we shrink the analogy further, the scale remains beyond us. If the observable universe were reduced to the size of a football field, the Milky Way would be smaller than a single atom, invisible even under a microscope. If the observable universe were a beach, our galaxy would be smaller than 1 grain of sand on that beach. And even that grain would contain hundreds of billions of stars. Imagine walking along that shore holding a single grain between your fingers and realizing that within it lies every light in the night sky, every sun, every planet, every human life, every moment in history. That's the scale of the cosmos. The infinite within the infinitesimal. And if our galaxy is that grain, then what does that make our solar system? Even smaller. So small that it would be a molecule within that single grain of sand. The sun itself, that fiery sphere we depend upon for every heartbeat and breath, would be no larger than a dust particle within that molecule. And Earth? Earth would be a subatomic point within that dust. Too small, too transient, too fragile to be drawn or even imagined. Our entire planet, with its mountains and oceans, its civilizations and stories, its love and violence and art and memory, all of it would vanish into an abstraction. This is the cosmic truth that the comparison forces upon us. The Milky Way, vast beyond comprehension in one frame of reference, becomes meaningless in another. We are caught between scales, too large to notice the quantum foam that flickers beneath reality, too small to truly perceive the grand design that stretches across billions of light years. From the cosmic perspective, even galaxies are as fleeting and delicate as snowflakes, forming and dissolving over eons, their light fading into darkness long before the universe is done expanding. And yet, somehow impossibly, within that speck of dust, within that vanishingly small mote of starlight, consciousness arose. The universe built eyes for itself, and they opened here on this tiny blue planet, orbiting one unremarkable star in a faint spiral arm of one faint galaxy among trillions. From within that almost invisible grain, life learned to look outward, to measure, to imagine. The Milky Way may be smaller than a speck of dust compared to the observable universe, but it is a speck that knows. It is a speck that can contemplate its place within the infinite. That perhaps is what redeems our smallness, not our scale, but our awareness. The comparison doesn't diminish us, it exalts us. For even though the Milky Way is smaller than a dust mote when set against the whole, it contains beings capable of understanding that fact. Within this microscopic grain, the universe reflects upon itself. That act, the act of comprehension, transforms insignificance into meaning. But even this meaning, even this vast 93 billion light-year arena, is only the visible portion of something greater. Because observable does not mean complete. There may be infinitely more beyond what we can see. More galaxies, more cosmic webs, more universes beyond universes, expanding forever into the unknown. Which means that even this immense comparison, Earth-sized universe, dust-sized Milky Way, is still not enough to convey our true smallness. Beyond the observable boundary lies the rest of creation, unseen, unmeasured, and perhaps unreachable. So before we move outward once more, before we step beyond the limit of light and visibility, we must pause here, in awe. We must acknowledge what this comparison teaches us, that in a universe where galaxies are dust motes and dust motes are worlds, existence itself is an act of wonder. To be aware within this scale is to be both infinitesimal and infinite at once. The term observable universe carries an invisible weight, one that most people never pause to unpack. When scientists speak of it, they're not describing everything that exists. They're describing everything we can see. That one word, observable, hides an ocean of uncertainty. It is not the true boundary of reality, but rather the edge of our cosmic horizon, the limit to which light has had time to reach us since the universe began. Beyond that horizon, space continues, galaxies continue, the universe continues. We simply cannot see it. Light has a finite speed, and time itself has a finite age. Since the Big Bang, 13.8 billion years have passed. And though the universe has been expanding all that time, light has only been able to travel so far. The result is a spherical bubble of visibility centered on us, 93 billion light-years across. Everything inside that sphere is observable. Everything outside of it is hidden, not because it doesn't exist, but because its light hasn't reached us yet. Those regions are too far away, too receded by the expansion of space for their ancient photons ever to arrive. And this realization changes everything. It means that when we say the universe is 93 billion light-years wide, we are not describing the whole universe, only the portion visible from Earth. We are, in essence, trapped within a glowing sphere of information, surrounded by a vast and unknowable darkness. Beyond that darkness, the universe could go on forever. There might be not 2 trillion galaxies, but hundreds of trillions, or an infinite number. There could be entire cosmic webs larger than Laniakea, entire realms of galaxies structured in ways we cannot yet imagine, their light forever sealed beyond the limits of observation. The word observable is a boundary drawn not by the universe itself, but by time. The cosmos is like a vast ocean, and we are standing on a small island at its center, watching waves of ancient light crash against our shore. Every photon that reaches us is a survivor, a traveler from a time when the universe was young, but there are waves that have not yet arrived, waves that may never reach us. The ocean extends farther than we can ever sail, and the shore of our observation will always remain a moving horizon, retreating faster than we can chase it. Because the universe is expanding, that horizon isn't static. The galaxies we see at the edge of visibility today, those faint red-shifted smudges billions of light years away, are moving away from us so rapidly that their light emitted now will never reach us in the future. In fact, as time passes, more and more galaxies will slip beyond that horizon, their light stretched into invisibility by the accelerating expansion of space. The observable universe is shrinking in visibility even as it expands in scale, a paradox that defines the nature of cosmic observation. What we can see now is only a temporary snapshot of a much larger, ever-evolving whole. This leads to one of the most humbling truths in all of science. We will never know how big the universe truly is. It may be finite, curved back upon itself like the surface of a vast hypersphere. Or it may be infinite, extending endlessly, with galaxy after galaxy stretching beyond any possible comprehension. Both are equally plausible, and both make our Milky Way impossibly small in context. If the universe is truly infinite, then our galaxy, our 100,000 light-year-wide spiral of stars, is smaller than a single atom within an infinite ocean. Every galaxy we can see, every cluster, every supercluster, would make up only a grain of cosmic foam floating on the surface of eternity. If the universe is finite but vastly larger than the observable part, then our Milky Way remains no less minuscule, a single droplet in a cosmic sea billions of times wider than anything light can ever show us. And yet this limitation, this boundary of the observable, is not a failure. It is a marvel. It reminds us that even from our narrow window of perception, we have been able to glimpse the grandeur of existence stretching almost to infinity. From one planet orbiting one star in one galaxy, humanity has measured the age of the cosmos, mapped the shape of the cosmic web, and traced the first flickers of light from the dawn of time. We have seen as far as light allows. And beyond that we have learned to imagine. But the humility of the word observable should never be forgotten. It is a reminder that every map we make of the universe is incomplete. The universe is not a picture we can frame. It is an endless, expanding reality of which we can see only the smallest, brightest part. Everything beyond the observable limit lies forever hidden from us, existing in a silence that no telescope can ever pierce. And that means our Milky Way, already smaller than a speck of dust within the observable cosmos, may be infinitely smaller still within the total universe. A mote inside a mote, a breath within a breath. When you stand beneath the stars and gaze upward, you are not looking into the entirety of space, but into a small illuminated bubble, surrounded by a darkness so vast it may never reveal itself. We exist in a kind of luminous island, a bright finite realm adrift in an infinite sea. To realize that, it is not to despair at our smallness, but to marvel at our scope of perception. Even confined to this tiny bubble of light, we have discovered our galaxy's insignificance and the universe's grandeur. We have seen the boundaries of visibility, and in doing so, touched the edge of the unknowable. And beyond that edge lies the great silence, the unseen, the unmeasured, the infinite. The Milky Way, our luminous home, drifts quietly within this tiny, shining sphere. One galaxy, among perhaps endless others. A reminder that in the grand total of existence, even the infinite has room for something smaller still. What does it truly mean? To understand that the Milky Way, our shimmering galactic home, is not the centerpiece of the universe, but just one of countless others drifting quietly through the dark. It means confronting a truth that is at once humbling and liberating. We are not special in size, in place, or in cosmic privilege. Our galaxy is not the axis upon which the universe turns, nor is our star the brightest, nor our planet the most extraordinary. The Milky Way is one thread in an immeasurable tapestry, a single swirl of light among billions suspended in an eternal stillness. For thousands of years, humanity imagined itself at the heart of creation. We believe the sun revolved around the earth, that the stars were fixed lights in a small celestial dome, that the universe was built for us. Even when we learned that Earth orbited the sun, and that the sun was one star among many, we still clung to the illusion of centrality. The belief that our galaxy might be the universe's great hub the grand cosmic city from which all others spread. But now, as we look outward with eyes of glass and silicon, we know better. We see that the Milky Way is not a capital, not a citadel of the cosmos, but a drifting spiral in an ocean of others just like it. Everywhere we look, we find galaxies, vast and beautiful, each a world of its own. They spin and collide, form and fade, born from the same laws that gave rise to ours. There are galaxies far larger than the Milky Way, their cores blazing with unimaginable energy, home to black holes billions of times the mass of our sun. There are galaxies smaller and quieter, irregular clouds of stars floating like mist in the void. There are elliptical giants whose light stretches across space like soft halos, and faint dwarfs that barely glow at all. In their variety, we see not our uniqueness, but our belonging. The Milky Way is one member of a family so vast that counting it is impossible. This realization that we are not the center does not diminish us. It frees us. It lifts the weight of imagined importance and replaces it with something deeper, connection. The Milky Way is one of billions, yes, but it is also part of something larger, an expression of the same cosmic process that built the universe itself. The stars in our sky are made from the same elements as those in Andromeda, in the Virgo cluster, and galaxies on the farthest edge of the observable universe. Every atom in your body, in your blood, in your breath was forged in the heart of a star, perhaps long ago, in a galaxy now too distant to ever see. When we realize this, the borders between galaxies cease to matter. The universe becomes one living entity, and we, through the Milky Way, are part of its heartbeat. Our galaxy drifts through space at hundreds of kilometers per second, orbiting the center of the local group, slowly falling toward Andromeda in a dance that will last billions of years. To an observer far away, the Milky Way would appear as a glowing spiral, faint but graceful, rotating silently in the darkness. From the cosmic perspective, it is not even moving in any purposeful way. It is simply carried along by the flow of the expanding universe, one fleck of brightness adrift on a tide of space-time that never stops. It neither leads nor lags. It simply is, suspended in cosmic motion. And yet within that quiet drift, within that single spiral of stars, something extraordinary happened. Amid the billions of suns scattered through its arms, around one small average star, a planet formed, rich with water, with air, with warmth. From its surface, life arose, small and fragile, yet curious enough to look back toward the heavens. That life eventually gave rise to us. Creatures capable of seeing beyond our galaxy, of realizing our place among the stars. In that sense, even though the Milky Way is not the center of the universe, it is the center of our universe, the stage upon which consciousness first opened its eyes. It's a paradox worth holding. We are insignificant, and yet profoundly significant. The Milky Way is one among billions, yet it is the one we inhabit, the one that has shaped everything we know. It is our cradle, our context, our cosmic address. Its arms have been our ancestors' compass and our scientists' laboratory. Every culture, every civilization that has ever existed has lived beneath its glow, beneath that faint river of starlight that arcs across the night sky. That band of light, so familiar, so ancient, is our only direct glimpse of the galaxy that contains us. We can't step outside it, we can't see it from afar, and yet we are part of it. We are within it, looking out through its veil of stars caught between awareness and wonder. To reflect on this truth, that the Milky Way drifts among countless others, is to let go of the illusion of centrality once and for all. It is to understand that the universe does not need a center, because it is not built like a map, but like a wave. It expands everywhere at once, with no edge, no middle, no up or down. Every galaxy, from ours to the most distant we can see, experiences itself as the center of its observable universe. Every world, every observer, stands at the middle of their own cosmic horizon. There is no privileged place, only countless perspectives woven together into the same infinite fabric. So, when we say that the Milky Way is not the centerpiece of the universe, we are saying something profound. There is no centerpiece. The cosmos does not revolve around any one thing. It simply is. Vast, expanding, self-sustaining, magnificent. In that vastness, the Milky Way drifts like a leaf in an endless current, one of billions carried along by forces older than time itself. And yet that drifting leaf is our home. It is where the universe for the first time looked back upon itself and said, I am. From within the spiral arms of an ordinary galaxy, in the outskirts of an ordinary supercluster, in a small corner of the observable universe, consciousness arose. And that, more than anything, is the miracle. The Milky Way does not need to be the center of the universe to be sacred. Its smallness is not a weakness. It is a testament to the vastness of creation. We are not diminished by knowing our place. We are illuminated by it. For in understanding how small our galaxy truly is, we come to see how vast the universe must be to contain something so beautiful, and how extraordinary it is that we, from within this tiny spiral of stars, have learned to see it all. From all that vastness, from the immeasurable grandeur of Laniakea, the infinite reach of the cosmic web, and the silent enormity of the observable universe, we return home, to Earth, to the small blue world orbiting an average star tucked away in the suburbs of an unremarkable spiral galaxy. In the scale of everything we've traversed so far, humanity occupies a point so small it may as well not exist. And yet, from that point, we have dared to look outward, to measure, to question, to comprehend the incomprehensible. Every discovery about the cosmos begins here, on a world just 12,742 kilometers wide, orbiting a star that is one of hundreds of billions in our galaxy. We have not stepped beyond our solar system. We have not visited another star. We have not crossed even the tiniest fraction of the Milky Way's 100,000 light-year span. In truth, we have barely left our front yard. The farthest any human-made object has ever traveled is Voyager 1, launched in 1977, now drifting through interstellar space about 24 billion kilometers away, less than 0.0025 light-years. If the Milky Way were scaled down to the size of Earth, Voyager 1 would not even have left the atmosphere. Humanity's entire reach, all our exploration, all our ambition, it still lies within the most infinitesimal speck of our own galaxy. And yet, from this tiny world, from this small patch of cosmic dust, we have learned to map the universe itself. Our telescopes, our equations, and our curiosity have reached distance our bodies never will. We have measured the faint afterglow of the Big Bang, radiation that has been traveling for nearly 14 billion years. We have detected the gravitational pull of black holes millions of light years away. We have seen the light of galaxies whose photons began their journey before Earth was even formed. Through the fragile instruments we've built with our own hands, we have extended our vision across the cosmos. That is the paradox of our species, so small and yet so infinite in mind. We are confined to one world, but our imagination moves freely through billions of galaxies. We have no wings, but we soar farther than light. The human brain, 3 pounds of delicate tissue, has contained within it the structure of the universe, the realization that we live on a tiny rock orbiting an average star in a sea of countless suns. We are the only known creatures who can look at the stars and grasp their scale, who can understand our own insignificance, and still find meaning in it. Think about what we've accomplished standing on this one world. In the short span of human history, we've gone from staring at the night sky in wonder to sending machines beyond the edges of our solar system, to building telescopes that can peer back to the first galaxies ever formed. We've learned the age of the universe, the composition of stars, the structure of galaxies, the nature of gravity, and the invisible presence of dark matter and dark energy. We've learned that our Milky Way, once thought infinite, is but one among 2 trillion galaxies. And yet, even with that knowledge, we continue to look upward in awe, as our ancestors once did. The wonder remains. In all the universe, there may be no act more profound than this, that a species of finite beings confined to one small world can look out into infinity and begin to understand it. We are the universe becoming conscious of itself. Atoms forged and ancient stars now looking back and recognizing their origin. Our eyes, our telescopes, our mathematics, they are the tools through which the cosmos studies its own creation. Every calculation we make, every photograph we capture from deep space is a conversation between the universe and its own reflection. Yet for all that achievement, our physical reach remains so fragile, so small. The moon, a mere 384,000 kilometers away, is the farthest any human has ever traveled. Mars, still unvisited by our footsteps, sits tens of millions of kilometers farther, a journey we have only just begun to dream of making. The nearest star, Proxima Centauri, is 4.24 light-years away, a distance that would take our fastest spacecraft tens of thousands of years to reach. The galaxy beyond, completely out of reach. The distances are too vast, the energy requirements too extreme, the time too long. For all practical purposes, we are confined to this one planet, a single island in a sea without shores, and yet that does not diminish us, because the greatness of humanity has never been in its size, but in its vision. We are the product of a universe that gave rise to awareness, to beings capable of wonder, reflection, and love. We have turned our smallness into our strength, our fragility into our motivation. We do not need to cross galaxies to touch them. We do so through knowledge, through imagination, through the sheer audacity of curiosity. Look around for a moment. Everything we are, every person, every story, every dream, exists on the single blue world, orbiting a single yellow star, 27,000 light-years from the center of a galaxy that drifts unnoticed in a universe without end. Yet from this vantage, from this infinitesimal point of light, we have named the stars, mapped the galaxies, and traced the origins of time itself. That is not smallness, that is greatness. When you realize how vast the universe is, it might be tempting to feel insignificant, to think that a single human life cannot possibly matter against such a backdrop. But if you step back and see the larger truth, you'll notice something profound. The universe does not know itself without us. It took 13.8 billion years of cosmic evolution, of stars being born and dying, of elements forming and merging, of galaxies spinning in silence, to produce consciousness capable of reflection. We are not the center of the universe, but we are its eyes. We are the witnesses through which it perceives itself. So yes, we have explored only one planet, orbiting one star in one small corner of one tiny galaxy. But through thought, through science, through wonder, we have explored the universe itself. We have reached with our minds farther than our bodies ever will. And in doing so, we've proven that scale does not define significance. What defines us is the act of reaching, of daring to understand. Because in the end, that's what humanity is. The universe reaching back toward its own beginning, trying to comprehend its own infinite story. And though we are small, though our home galaxy is just one among billions, we are the part of the cosmos that dreams. When we finally stand back far enough, when our minds stretch beyond the comfortable boundaries of imagination, and we truly grasp the scale of the cosmos, a single truth crystallizes with a breathtaking clarity. The Milky Way isn't vast. It's fragile, fleeting, and small beyond imagination. It's almost impossible to believe that something containing hundreds of billions of stars could ever be described as fragile. And yet, compared to the timeless immensity of the universe, is just that. A delicate, transient structure built from the ashes of dying stars, held together by gravity's gentle pull, destined one day to fade away. The Milky Way has existed for roughly 13 billion years, and in a few billion more it will collide and merge with the Andromeda Galaxy, becoming something entirely new. The elegant spiral we see today, that luminous river stretching across our night sky, will eventually dissolve, its arms disrupted, its stars scattered into new orbits. Even galaxies, those titans of space, live finite lives. In cosmic terms, they too are mortal. The universe itself will outlast them all. Long after the Milky Way's spiral arms have vanished, long after the last star has burned its final drop of hydrogen, space will remain, cold, silent, expanding ever outward. Time will stretch on, and the light from what was once our galaxy will travel into the dark, fading into nothing. What was once our cosmic home will become a whisper, a ghost of light swallowed by infinity. That is the destiny written into every galaxy, to be born, to shine, and to disappear. And yet, knowing that, understanding how fleeting even a galaxy is, doesn't diminish the Milky Way's beauty. It deepens it. For a moment, against impossible odds, it exists, a vast spinning collection of stars, dust, and worlds suspended between the voids. It is fragile not because it's weak, but because it is temporary, a brief flicker of order in a universe that tends towards stillness. That fragility makes it sacred. When you look up at the night sky and see the pale arc of the Milky Way stretching above you, you are seeing something that exists in perfect balance between creation and collapse. Every point of light in that band is a sun, many of them with planets. Many of those planets perhaps with their own skies, their own oceans, their own eyes looking back. And yet all of it together, it's every star, every world, every atom fits within a galaxy that, in the scale of the cosmos, is smaller than a dust mote. To realize this is to feel the most humbling kind of awe. The Milky Way is not the infinite realm it appears to be when seen from our tiny corner of space. It is a passing phenomenon, one beautiful shape in the endless flow of cosmic time. We are fortunate beyond measure to exist here now, during its age of brilliance. To live on a small planet orbiting a small star while our galaxy still glows in youth. One day that light will fade, the stars will die, the gas will cool, and the galaxy will become dark. The universe will grow silent again, but that day is far away, billions upon billions of years in the future. For now we are here, alive within this fragile span of brightness, witnessing the miracle of existence. And perhaps that's what this journey, from illusion to understanding, has been about all along. To recognize that we are not large, not central, not infinite, but part of something that is. To understand that smallness does not mean insignificance. That fragility itself is the essence of beauty. The Milky Way is small compared to the cosmos, yes, but it is also miraculous. Because within it, for the briefest heartbeat of eternity, something emerged that could see the stars and understand them. We often talk about scale in terms of distance and size, but there's another kind of scale. The scale of meaning. The same universe that reduces our galaxy to invisibility also gave rise to beings capable of love, of curiosity, of wonder. That means something. It means that even though the Milky Way is small, the experience of seeing it, of knowing it, is vast beyond measure. So when we stand beneath the stars and trace that glowing band across the night, we should do so with humble wonder. We are looking into the heart of something that is both infinitely beyond us and deeply within us. The atoms in our bodies were born in those same stars. Their light is our history. Their gravity holds our world in place. We were made of this Milky Way, and it, for a moment in time, is made about to wear through us. And that is the great paradox of existence. We are tiny beyond comprehension, and yet through consciousness we hold the infinite within us. The Milky Way, our fragile home, is small beyond imagination. But within its smallness, the universe has found a way to see itself, to feel awe, and to know that it's beautiful. That is the gift of perspective. That is the quiet truth waiting at the edge of understanding. The Milky Way is not vast. It's a delicate breath in the endless symphony of creation, and we are fortunate enough to be here listening. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.